conservative fields and the potential functions in this section. So what are vector fields? Vector fields are, they describe phenomena such as current, wind direction, electric and magnetic fields over 3D, over n space. So basically they are functions input. There are n input for them and n output. So you can write it like this. You can write f of, for example, in 3D, f of x and y and z is equal to f1 of x, y, and z, f2 of x, y, and z, and f3 of x, y, and z. So for each point on this space, that's a point in the space, a point in the space, input, does input have an E? No. Okay, so you get a vector output. So you go to the space and you basically put in needles in the space, little vector needles in this space. I'm literally serious. We should have a dance party in this one of your classes. Seriously, you guys are doing it too many times. Okay. Well, let's do that. So yeah, that's the story. And so you can see if for n space, you will have a point in n space input and a vector in n space output. The picture that you see, that's a magnetic field in 2D. These are other examples of vector fields. Oh, what is this one? In the chat. A tornado. So that's the airflow, right? What is that one? It's the hurricane. You can say airflow again, or you can say water flow sometimes, right? Or droplets flow. And that one is a magnetic field of the earth. You see these are like the lines are connected. If I want to draw a vector field, I don't draw the connected first. In your whatever discipline you are, you may do that also. But what I do is I look at points in the space. And find, give yourself examples. For example, for this one, I'm going to give myself a bunch of points in this space. X and Y to be, I don't know, 0, 0. I want to give 1 and 0. I want to give 0 and 1. I want to give 1 and 1, a whole lot of those, right? And then I plug in 0, 0. So E of X and Y. So E of 0 and 0 gives me negative 0 and 0, which is 0, 0. E of 1 and 0 gives me negative y. What is y? 0. Negative 0. And x. X is, remember, it's negative y and x. Negative y is 0. And x is 1. So it's 0 and 1. E of, E of, oh, I'm out. Okay, I see. Okay, I'm out of time. But that's how we start. So next thing that I do is I try to graph it for you by that method. So what I'm doing is going to go, let's say 0.00, the vector is 0. At point 1 and 0, the value was -1 and 0. So I would graph a vector with -1 and 0, which is this way. And all these different ones. And did I do it right? No, that's wrong. Sorry. That one is wrong. It's going to be, you just find it and you go to the point in the space and then you draw the vectors. Sorry about that. I'm done. What is the yeah, it's just vector fields are assigning vectors to points in the space. You compute the, you compute.
So it would give you a vector and then we pick the point to test.
So here's the thing. This formula gives you a vector to every point in the space. But I need
okay.
the sort of understanding